Okay, welcome everyone to this session. So we are going to talk about the deployment of Kubernetes clusters on a multi-cloud environment. And we are going to use the OpenNebula Kubernetes Engine and the OpenNebula multi-cloud capabilities. My name is Marco Mancini. I am a senior cloud solution architect at OpenNebula. And with me today in this session, there are other two colleagues, two great speakers, Andres Valero from SUSE and Jesus Macia Portela from Telefonica. Welcome to both of you and also to all the attendees for this session. I would like to remember the attendees that you can use the chat on this same page where you can send questions so we can reply to your session. To your questions. So this session has been organized by, in collaboration with the European project 6G Sandbox. Okay, so let me start by introducing the OneKE appliance, so the OpenNebula Kubernetes Engine. So this is a minimal hyper-converged Kubernetes platform that comes with OpenNebula, so you can find in the OpenNebula marketplace, public marketplace, and is based on RKE2, the Rancher next generation Kubernetes distribution that will be explained later by Andres, and is integrated with other pre-installed components because you can manage volume persistence with Longhorn. And also ingress traffic. We have integrated the traffic. You can manage load balancing on premise because we have integrated MetalLB. So it's a Kubernetes engine with these pre-installed components. So it's just full-featured out of the box from the OpenNebula marketplace. So the OpenNebula engine Kubernetes engine has been defined as a one-flow service. So one-flow in OpenNebula allows you to define, execute, and manage applications that are multi-tier. So they're called service. So where you can have multiple VMs, and each group of VM represents a role. In this case, for the Kubernetes engine appliance, we have 4 roles. So we have the VNF, that is a multi-node, so in high availability, that provides load balancing for the control plane. And it also provides NAT and routing for the Kubernetes engine because it's based on 2 networks. So we have one private networks for the different roles, like masters, workers, and storage. And then we have a public networks where just the VNF is connected, so you can then access the Kubernetes clusters by using the VNF. So it provides routing internally between these 2 networks. The master role is responsible for running the RKE2 control plane and also managing the other components that are used for managing the cluster. So the etcd database, the API server, and so on, and manages also the worker nodes. The workers, the main role is just where you would like to run your workloads. And then we have the storage nodes that are designed to run only Longhorn replicas that we use for persistent volume. Also, Longhorn will be then explained by Andres in the next presentation. Okay, so let me go to the demo. So I prepared a demo in order to show you how you can deploy Kubernetes cluster by using OpenNebula, but also will show you how you can expand your cloud environment with that maybe use only on-premise infrastructure with the resources that can come from public cloud providers like AWS or Equinix. So you can use the OneProvision tool to import edge clusters defined on, for example, on public cloud. And then what I will show is how you can import the appliance from the public marketplace, and then you can instantiate a Kubernetes clusters on different edge clusters belonging, for example, to different cloud providers. And then I will just show how you can use kubectl to connect to one of these Kubernetes clusters and just launch a simple application. So let me start with the demo. So here we have the dashboard of OpenNebula, the Sandstone graphical user interface. As you can see here, we don't have any host. We have just a default cluster defined, but we don't have any host. So what we are going to do now is to use one provision to create edge clusters on public cloud. So we are going to use AWS and Equinix. So I already defined a couple of providers. So one for AWS London and one for Equinix Amsterdam. Here, I'm going to create first an edge cluster by using the AWS provider for London zone. Here, you can also configure your cluster. For example, you can define your numbers of IPs, the numbers of hosts, the type of instance that you would like to use, and so on. And now the provisioning is starting. I do the same for Equinix. Here I'm going to select the Equinix Amsterdam provider. And as before, we can use some settings here to define the numbers of IP, the numbers of hosts, and so on. In this case, I just create one host and one public IP. One provision use as backend Terraform and Ansible to provision. This will take 5-10 minutes according to the provider. As I switch to the Sandstone, you can see now the host that has been provisioned. So this takes some time. So as I said, after 5-10 minutes, you can have your host and your cluster defined in your Sandstone interface. A couple of networks has been already defined, the public ones, and 2 templates also have been created for creating these private networks that we need for the Kubernetes cluster. So I'm going to create a private network for the Equinix cluster in this case by instantiating the template that has been created during the provision. And then I can do the same for the AWS cluster. So I create another private network also for the AWS cluster. And once you do this, we have both networks that are needed for the Kubernetes cluster, so the public ones and the private ones. And this can be displayed in the virtual networks now tab of the Sandstone interface. I'm going now to import the OneKubernetes Engine appliance by accessing the public marketplace. So you can search by using the filter, and then you can import on your cloud environment. This will import different things. So it will import the template for the service, the templates for the different roles for the VMs. So for the master, the VNF, the workers and the storage, and it will import also the images, the corresponding images for each kind of role that we have defined in the service template. Once you have imported the appliance, you can use the service to instantiate a new Kubernetes cluster. So in order to instantiate on one of the edge cluster that we have provisioned before, what you have to do is to select the public and the private networks that belongs to that cluster. So in this case, I'm going to create for the AWS, and I have to also put a couple of IPs for the control plane and the default gateway. And then I just click create, and this cluster is now going to be deployed on AWS. I can do the same also for Equinix. So I use the same service template, but in this case, I'm going to select the public and the private networks of the Equinix edge clusters. In this case also, I can put this IP that belongs to the private networks for the control plane and the default gateway. So once I have created the 2 services, one flow will start to deploy the different roles. So the VNF is the first role. Since one flow can manage dependencies, in this case, VNF should be ready in order for one flow to deploy the other roles. So when the VNF is ready, as you can see, also the master, the worker, and the storage role have been deployed. So in this case, we have one VM for each role. So this is not in a production mode, so not availability, because you need multiple instances of each role in order to have availability. So in order to connect, you can use the IP, the public IP of the VNF, and then use it SSH. You can use forwarding to the master that is available on a private network. Now I am connected to the master node, And then here I can use the kubectl tool in order to, for example, checking the nodes that in this case are ready. And for example, running an image like Nginx. So I will now create a pod and that will use Nginx as an image. And once you do this, for example, since this cluster comes with an ingress controller already pre-installed traffic, you can define a manifest file that allow you to access the service, in this case Nginx, from the public network, in particular by using the public IP of the VNF. So here I've created a manifest file to expose this pod, this service, and using traffic. So once you apply this and you deploy on your Kubernetes cluster, then you can use the public IP on the VNF, and then you can access the Nginx application. So this is the welcome page. As I said, in this case, we have only one VM for each role, but what you can do is you can scale, because OneFlow allow you to scale the roles. So in this case, for example, I'm going to scale to 2 workers. So when I use the scale for the worker, and now, as you can see, a new VM has been created for that role by OneFlow, and so the cluster we will have 2 workers for this cluster. Okay, so I think the demo is done, and I can now switch to my colleague Andres Valero from SUSE.
My name is Andres Valero. I work as a technical marketing manager at SUSE, and I've been working in IT for a while. I've been a solution architect, consultant. I've been working also in sales. So let's say I've been doing a little bit of everything. But let's go for the important stuff. So RKE2, origin, features, and why using RKE2. So basically, in 2020, SUSE acquired Rancher Labs, and Rancher Labs back at the time and also now have what is called Rancher Government Solutions, which is a branch that is dedicated to the US government and what they need in a matter of application, containers, Kubernetes, etc. So the US government basically reached out to RGS and told them, hey, we need a Kubernetes distribution that is security-oriented, that is easy to operate, that is as close as possible to upstream Kubernetes, and we also need that it is deployed with a single binary. So we already had at home, let's say, RKE and K3S. And luckily for us, these 2 distributions provided most of what the US government were asking. So the Rancher Labs engineers decided to get the best from K3S, the best from RKE, and make something new that was RKE2. RKE2, it's a distribution that can run on many operative systems. So you can see OpenSUSE, SLE Micro, Ubuntu, CentOS. Even you can use Windows workers with Windows Server 2019 and 2022. The hardware requirements are low, 8 gigs of RAM for CPU as recommended, but it can run with less. And remember, RKE2 is the closest possible to upstream Kubernetes, so it uses etcd, and etcd needs SSD disks to work properly, to have no problems with the etcd database. And as Marco was showing you before, deployments can be made in a single mode fashion, compact cluster 3 nodes, or HA. You just need to adapt the roles accordingly, and deploying, for instance, if you start with a compact cluster, deploying more nodes is as easy as get the token that RKE2 generates, send it with the command to the new node, and changing the roles. So if now it's going to be a worker, just labeling it as a worker, and voila, it's super easy. And the same if you decided to deploy a fully HA cluster. Now let's talk about the features. So the features are, as we expected, so easy to pass the CIS Kubernetes benchmark. So it is pre-configured and provides you with the tooling to pass the CIS benchmark. It enables by default FIPS 140. So you have a more secure environment and you make sure that everything is properly encrypted. So it's also compatible with AppArmor, Linux, and MCS. So you can enforce security on your nodes, making sure that everything is secured. Every single code push that is sent through the pipeline to build the images for RKE2 is scanned for CVEs, and if the CVE is detected, this image is upgraded accordingly or patched. So let's say we make sure that everything is in place. Also, there's the sleep-based container image or BCI. So the images are based on SUSE Linux, which is a quite secure or one of the most secure Linux in the market. Also, it's easy and fast to install and scale. It supports, as we said, Windows workers. It is fully integrated with Rancher Manager. So if you want to use Rancher Manager, you can. And you have quite a lot of plugins that can be used. So you can see here, Canal, Calico, Cilium, Multus for SR, AOV. So there are different use cases and you can cover it with different plugins. And now I will introduce you a little bit of Longhorn. And basically, what is Longhorn? Well, Longhorn is a highly available software-defined persistent storage for block and file in Kubernetes. So it's cloud native, it's fully oriented to run on Kubernetes. Compared with other solutions or other projects, it's lightweight, is really reliable and easy to use. It can be deployed from Rancher with just one click, but you can use also Helm chart to deploy it, which is make it extremely easy to deploy. And what makes a special Longhorn? Basically, it can work in any CNCF Kubernetes cluster. Longhorn also is part of the CNCF. Rancher Labs donated Longhorn to the CNCF in 2019. And this is all what I wanted to tell you today, and thank you for your time.
Okay, thanks, Andres, for talking about and showing about this the two technologies, RKE2 and Longhorn. Now we can move to the next speaker, that is Jesus, that he will share their first-hand experience on using and leveraging Kubernetes, OpenNebula, by deploying 5G cores to the edge. Okay, so let Jesus, you can have the floor and you can proceed with your presentation. Thanks.
So thank you, Marco. Hello, everyone. My name is Jesus Macias, and in the last few years, I have been working at Telefonica on different innovation projects, mainly focused on edge computing, virtualization, and network performance, where OpenNebula has been a key player in obtaining good results. So we started more than 6 years ago, designing the transition of a traditional central office to a small data center where we can deploy it from the operator's systems to provide services such as voice, television, or internet, all virtualized, up to new use cases where taking advantage where the edge will add value, such as gaming via streaming, having very low latency, or video CDN, reducing Telefónica internal traffic and also cost. So our perception has always been that OpenNebula met our requirements at any level in a very simple way. So we are very happy to continue working with them in new projects. So at this point, I would like to continue with the presentation by giving a little context about the 6G Sandbox project. So with the beginning of the year, the 6G Sandbox project began, and Telefónica and OpenNebula as consortium partners have been working on different tasks. 6G Sandbox project aims to create a platform where experiments around 6G networks can be deployed in the simplest way. So to achieve that objective, we need to design a platform based on modularity, on open access, on reusability, innovation, sustainability. And also we need to integrate new technology in some cases in a state of a very preliminary maturity. For now, we are working on defining a private cloud architecture to support the platform in the Malaga testbed, because we are going to have 4 different testbeds, one in Malaga, one in Athens, one in Berlin, and one in Oulu. And also we have been working in the automation of the deployments and the integration between the components and the equipment of the 6G library through open interfaces relying on standards. So to configure these experiments, a 6G library will be created. The 6G library will be something like a building blocks. With that building blocks, we will be able to find modules and physical equipment that will be used to create the definition and deployment of a logical element that we call trial network. So a trial network should be a fully configurable and manageable and controllable environment, combining virtual and physical components and modeling a 6G network environment, allowing experiments to be executed and capture a multitude of KPIs so that we be able to validate the new technologies that we want to test. So the 6G library is like a catalog of building blocks that we can put together to model the environment, the trial network, the context to run the experiment. So far, that context, now I'm going to explain how we use OneKE in this context. So for a few years, we have been experiencing a paradigm shift where all systems are being virtualized, so that everything is becoming software, emerging different ways to simplify deployments and manage application life cycles. So almost all telco vendors are following the recommendation of the Cloud Native Foundation. So right now we need platforms where we can deploy and manage microservices in the most efficient way. This is where OneKE comes in. So inside the trial network, we must be able to deploy applications and services that run in Kubernetes, but also without forgetting that OpenNebula give us the chance of running virtual machines and coexisting without problems. What you can see in the picture on the top represents many trial networks deployed in an OpenNebula, and in the bottom there is a detailed example of a trial network where we have a VM that acts as an entry point, because all the resources of a trial network are isolated from the rest of trial networks. And also we have a OneKE cluster, which by default give us everything that we need. We have scalability, we have automated deployment, we have an ingress controller, everything that we need. And also we can deploy some VMs if necessary, and we can control all of this through the standard application, the standards application in the industry. So we have right now automation that use Terraform to create the virtual infrastructure using the OpenNebula provider. We use Ansible to do some fine-grained configuration, and we use Helm to deploy applications inside the OneKE clusters. This is an example of our first trial network where we deploy a 5G core in a OneKE cluster, connects a physical radio equipment with the core inside the OneKE cluster, and also we had a mobile terminal connected to the radio, and that terminal is able to connect to attach to the radio and browse the internet. So the steps that we follow here is, the first one is we have deployed the virtual infrastructure with Terraform. So we create the virtual data center that hosts the trial network and all the components inside, the router VM and the OneKE cluster. In parallel, we use Ansible and Robot Framework to configure the physical radio equipment because we need to create some configuration on the Nokia equipment. The third step is once the OneKE cluster is ready, we use Helm to deploy the Open5Gs core inside the cluster. And the connection with the physical radio happens automatically. And the fourth step is, again, we use Ansible to configure a mobile subscription inside the database of the 5G core. So the mobile terminal is able to attach to the radio interface and create a tunnel with the core to start surfing internet. So to have this demo ready, we have deployed more than 100 OneKE clusters, and we have tested several CNIs until we found the one that best suits our requirements. So imagine that this is the simplest trial network that we are going to use, and right now we are iterating and introducing much more complexity. So we are very grateful to have a tool like OneKE that allows us to be much more agile and efficient, and of course, happier. So some conclusions to finish. For the 6G Sandbox project, the use of OpenNebula bring us many benefits out of the box. Simplicity, but if it's necessary, we can go at a very low level. Security by default, we have a central point to manage all type of workloads, and we can manage hundreds of OneKE clusters. Many automation enablers that allow us follow the same way of working as if we are using a public cloud. And also the OneKE service is certified by the Cloud Native Foundation that warranty the quality of the service. And to finish, 2 key learnings. The first one is that in telco environments are quite complex. And we have found situations where we need to integrate legacy systems with virtualized components at network level. So sometimes it's not only TCP or UDP traffic transport. Sometimes there is a lot of black magic within telco systems, and integration should happen without adding complexity to this picture. So we need as much flexibility as possible. For that, we have proposed many improvements to the engineering team, to the OpenNebula engineering team, and we are working together to have it soon. And the second key learning is that sharing experiences and knowledge is become the case to success of this project. We move faster because we have a continuous feedback loop. And this is very valuable. And well, we are very happy to contribute to a project with as much future as OpenNebula. And this is all. If someone wants to contact me for more details, I will be happy to talk with. Thank you.
Thanks, Jesus, for this great presentation and presenting this project using OneKE appliance. And so I would like to thank all these, both Andres and Jesus and all the attendees for this session. And don't forget that you can send a question and comments through the chat. So I thank you all and see you in the next session. Okay, bye.